Here we have an arithmetic expression for which we are required to find the answer, or just to simplify it to a single number. Multiplication takes precedence over addition. However, the sum is enclosed in brackets and must therefore be calculated first. But before adding, we have to square 5.8. Normally, multiplication is carried out before addition, but the addition is enclosed in brackets. The operations that are in brackets are carried out first. So we may add 5.8 squared to 1.02 before multiplying by 2.5. However, we need to find the square of 5.8 first. So that is our first step. Find the square of 5.8. Then we may go straight ahead and add the contents of the brackets. Finally, we will multiply the result by 2.5. And that is our final answer. We should not see any difficulty arriving at the correct answer. For us, it should not be a big deal. We may say such a problem by the CSEC is a waste of time. But I say it is not a waste of time. If one is not alert to the fact that although multiplication takes precedence over addition, brackets take precedence overall, then a mistake may be made. These problems are designed to test the most fundamental principles in mathematics. Without those principles that we sometimes take for granted, we cannot build a superstructure. Fractions. Before going into the manipulation of the fractions, let us convert the mixed numbers to improper fractions. Here's our first one. And for the first one, we are labeling the whole number part, the numerator, and the denominator. All of the different components of the mixed numbers are labeled. Multiply the denominator by the whole number, then add the result to the numerator. And that is our first step in writing the mixed number as an improper fraction. Multiply the whole number by the denominator. 2 multiplied by 9 is equal to 18. Then we add the result to 4. That number that we have there, 22, is the numerator of the improper fraction. And what about the denominator? The denominator will be the same as before. We may write the other mixed number as an improper fraction, but we are not labeling the different components on this occasion. 3 multiplied by 4 is equal to 12. We multiply the whole number by the denominator. That is equal to 12. Then we add that value to 2, which is 14. And what will that be? That will be the numerator of the improper fraction, and the denominator will be the same as before. On the next slide, the fraction bar that separates the mixed numbers will be replaced by the division sign. Here we have this fraction bar. Of course, we know that the fraction bar is signifying division. Therefore, if we replace it with a division sign, then there is no cheating there. Rewrite the expression with the improper fractions obtained on the previous slide. So these are the improper fractions. Replace 2 and 4/9 by 22 over 9, and so on. Next, we will replace the large fraction bar with a division sign and enclose the resulting expression in brackets. The expression will be correct without the brackets, but the visual effect created by them, we are talking about the brackets, the visual effect makes our intentions clear. It is plainer by including the brackets that we intend to divide 22 over 9 by 14 over 3, and that process will be carried out before we subtract 3 over 7. Without the brackets, the expression would have meant the same thing, because we will actually give precedence to division over subtraction. Division, at any rate, would have been carried out first before subtraction. Dividing by a fraction is equivalent to multiplying by its inverse. So whereas we are dividing by 14 over 3, we will multiply by 3 over 14. The resulting fraction may be reduced. We have a common factor of 3 for 3 and 9, and we have a common factor of 2 for 22 and 14. 2 into 22 is 11, and 2 into 14 is 7. 3 into 3 is 1, and 3 into 9 is 3. We may make use of a common denominator of the fractions. The common denominator is 21. One of the denominator is 7. To convert 7 to 21, we need to multiply 7 by 3. In so doing, we also need to multiply 3 by 3. So 7 multiplied by 3 is equal to 21. They have the common denominators. Then multiply by 3 here also, in order that the result is the same fraction that we have here, with the exception that it is in a different form or it has a different appearance. Now that they have equal denominator, we may subtract the fractions quite easily by subtracting the numerators and then writing the answer over the common denominator of 21. Right. Multiplying both numerator and denominator by 3 causes the denominators to be equal, making subtraction simpler. So multiplying this denominator by 3, we get 21. Multiply the numerator also by 3, we get 9. Of course, if we reduce this fraction by a common factor of 3, this is the result. So these fractions are actually equal. But we are writing this one in the form that it has the same denominator as 11 over 21. By so doing, subtraction is made easier. This does not cause any harm, because multiplying both numerator and denominator of a fraction by the same number does not affect its value. A company pays its employees a basic wage of $9.50 per hour for a 40-hour week. And we have that information right there on the screen. The hourly rate is $9.50, and that is for a 40-hour work week. To find the weekly wage, all we need to do is multiply the two values. That is, multiply the hourly rate by the number of hours in a week. And there's your result. Next, we are talking about an overtime payment here. And the number of overtime hours is 6. And overtime is calculated at time and a half. The overtime rate is time and a half. That has to be multiplied by the hourly rate when applied to overtime hours. There is no need to do one and then the other. They may be done at once. So there we have the result. Now we are saying that in order to find the overtime rate, we may multiply the overtime, which is time and a half, by the hourly rate. After doing that, in order to find the total amount for 6 hours of overtime at time and a half, we will then multiply by 6. So the overtime hourly rate may be found by multiplying 1.5 by $9.50. Then we may multiply that by the number of overtime hours. But we do not need to do that as two separate calculations. We may do that in one by multiplying the hourly rate by the 1.5, which is how overtime is calculated, and we multiply that by the number of hours. And there is our answer. The total overtime wage is the difference between the total given and the regular wage. We are considering 30 employees. Their regular wage is equal to the product of 30 and the weekly wage for one employee. So what we have here is a total of $12,084. And that is inclusive of basic and overtime wage. That amount is actually paid to 30 employees. The first calculation is the total paid in overtime wage. What is the meaning of all of this? Here we have the weekly wage for one employee. We multiply that by 30 because there are 30 of them. When we multiply 380 by 30, that is the basic wage for the entire 30 employees for the entire week. In order to find the overtime, we need to take that basic wage for 30 employees for the entire week from the total that was given. And this total is inclusive of the basic wage for the 30 employees plus any overtime that was worked. So all we need to do is determine now the amount that was paid for overtime hours. And we do that by subtract the basic for the 30 employees for the entire week. We subtract that from the total amount paid in that week. And this is our result. Our next step is to find the number of overtime hours worked. To find the number of hours, we need to divide 684 by the hourly rate. But we need to be reminded that it is overtime rate. We will divide by the product of the overtime rate and the hourly rate. This is overtime money. Therefore, the hourly rate for this is not $9.50. The hourly rate for this is actually $9.50 multiplied by 1.5, which is what we have right here. Therefore, in order to determine how many hours overtime that amounted to this amount, we need to divide this by the product of the hourly rate and the overtime, which is what we have right here. So we will divide 684 by the product of 1.5 and 9.5. And here we have it. The result is 48 hours in total. There we have our favorite algebraic fractions. There is no difficulty seeing that the common denominator of a fraction is 15. And that is the first thing that we need to consider in expressing that result as a single fraction. We will proceed as we usually do from primary school. So a lot of our principles from primary schools are still coming over. We may apply them. This time we are not applying them to pure number fractions. We are applying them to algebraic fractions. The principles are the same. So we'll say 5 into 15 is 3 and 3 2's 6. So we'll have 6x. We also say 3 into 15 is 5 and 5 times x is 5x. Don't forget this subtraction sign. Simplify the numerator. 6x minus 5x is equal to x, and that is all there is to it. Next problem, factorize completely a squared b plus 2ab. Factorize that completely. We may factorize the expression by taking a common factor of ab. We may get a common factor of ab because ab is present here and ab here. How do we factorize? We divide the common factor into each one of these. So ab into a squared b, the a will cancel one of the a's and a will be left, and the b's will cancel completely. Also, AB will cancel completely with AB right here, and we have 2. We may place the process of factorization under the microscope, in which we demonstrate that we take the common factor and divide each term by the common factor. So we have the same expression, and we will divide each one of the terms by the common factor. So the common factor is AB, it's right here. Then this term is divided by the common factor. This term is divided by the common factor. And we have no problem seeing that A will cancel with A squared, leaving A. The B's will go completely. Here we have AB and AB, and all that we will have inside of this bracket is A plus 2B. It is not necessary to demonstrate the intermediate step in an examination. This is just a demonstration of the finer details of the principle of factorization. Q is equal to P squared minus R over T. That we need to rewrite, making P the subject of the formula. We need to make P the subject of the formula. This means that we need to eliminate everything else from the right hand side. In the event that we have a denominator, as we have right here, a denominator, a very good first step is to eliminate that denominator. In eliminating the denominator, we need to multiply by t. because this denominator is something that we are dividing by. In order to eliminate it, we need to multiply by t, the entire equation. By so doing, t will be eliminated from the right hand side, and on the left hand side, q will be multiplied by t. Next, we need to eliminate this negative r. This may be achieved by adding r to both sides. By adding r to both sides, negative r will be eliminated from the right hand side, and on the left hand side we have qt plus r. Next, we have p squared. The opposite of square is square root. We will therefore find the square root of both sides. This will cause the square to be eliminated from the right hand side, and on the left hand side we will have the square root of all of qt plus r. It is appropriate to write the subject of the formula on the left hand side, and that is what we will do. The intermediate steps could have been included, but they will not attract any extra mark. They will only be taking up space and consuming precious time. So the intermediate steps, a lot of students like to involve the intermediate step as they go merrily along. It is not wrong, but it will not attract any extra marks. We will only be taking up space and consuming precious time. The table that we have right here is demonstrating that we have small box, and in the small box we have x donuts per box, and in the large box we have 2x plus 3 donuts. We have information that we are using in order to find the number of donuts in small box and number of donuts in a large box. The number of donuts is equal to the number in each box multiplied by the number of boxes, and we will see in a short while the number of each box. We have 8 small boxes of x donuts and 5 large boxes of 2x plus 3 donuts. Eight small boxes of x donuts, 5 large boxes of 2x plus 3 donuts. How many donuts do we have in all? The total number of donuts will be what? The number in each box multiplied by the number of boxes, then we add that to the number in the large box multiplied by the number of large boxes, and that is our result. Now we need to find the number of donuts in the different boxes. We must begin by finding x. The expression is equated to 195 because we have information in the statement of the problem that tells us that the total number of donuts is 195. We have an equation that we may solve. Notice that by the time we get to this step, to solve the problem, we expanded the bracket. So we have 5 times 2x is 10x, 5 3s 15. What do we do next? 8x plus 10x is equal to 18x. This positive 15, by transposition, we subtract 15 from 195 and we have 180. There is no difficulty seeing 18x 180, x is equal to 10. X is the number of donuts in a small box. X is equal to 10 donuts in a small box. What about the large box? The number of donuts in a large box is 2x plus 3. As we have right here, x is equal to 10. We will substitute 10 in the place of x inside of this expression in order to find the number of donuts in a large box. Two times 10, 20, plus 3, 23. There's nothing to it. Now we have problem 3, part A, that requires that we simplify an algebraic expression. There we have it. We will simplify the expression in which two terms are being multiplied. How do we do that? We will multiply the coefficients and add the indices of common bases. Where there is no visible index, the value of the index in that particular case is equal to 1, as we have it right there. Now for multiplication, we multiply the coefficients. And do not forget that when we multiply expressions or numbers that have the same base, we add the indices. So we will have 2 times 7, and for the indices of P we have 5 and 2, those will be added, and for the indices of Q we have 3 and 1, those two will be added. 7 times 2 is 14, then we have 5 plus 2 is 7 and 3 plus 1 is 4, and that is all there is to it. We need first in 3b to calculate the volume of milk in each box whose dimension is given here. And if we have a cuboid, the volume is equal to length times width times height. And we substitute those values, and there is no difficulty right there. V is equal to 240 centimeters cubed. The recipe makes use of 3 liters of milk. 1000 centimeter cube is equal to 1 liter. That is the conversion that we need to know. That 1000 centimeters cubed is equal to 1 liter. The recipe makes use of 3 liters. Therefore, we have to multiply 3 by 1000 in order to find the number of centimeter cubed involved. Then we need also to determine the number of cartons that will be equal to those 3 liters. How do we do that? To find the number of 240 centimeters cubed cartons in 3 liters, we will divide 3000, which is 3 liters, by 240. So we have a total of 3000 centimeter cubed, which is 3 liters, and that we will divide by the volume of milk in each box, and we will know the number of boxes. And that turns out to be 12.5, 12 and a half cartons. We already have a volume of milk in the cup. The only thing that is missing is the height. Let us begin by writing down the formula for the volume of a cylinder. Formula for a volume of a cylinder. Why are we doing that? Because the milk that is contained in a box is thrown into a cylindrical cup whose diameter is given, and we need to know the height of the milk in the cup. That's not difficult, because if we can write an equation with a single unknown, then there's no difficulty finding that unknown. Here we know the diameter, we know pi, we do not know the height. And of course this volume is equal to 240 centimeters cubed. That is also known. The only unknown there will be the height. So d is given as 5 and pi is to be taken as 3.14. Substitute those into the expression. And what do we know? That is to be equated to 240, which is the volume of milk in each carton, and hence will be the volume of milk inside of that cup. The only thing that we do not know is the height, as we can see right there. Transposing will result in the value of h. In transposing, everything that we divide by on this side will be multiplied on the other side, and everything that we multiply by on this side we will divide on the other side. Simplification will result in the value of h that turns out to be 12.2292 centimeters. The answer obtained is required to be written correct to 3 significant figures. There is the answer. Write that to 3 significant figures. The first part of the process is locate the third digit in order of significance by counting from the left, and at the left we will have the most significant digit. So we start right there. 1, 2, we are going to 3. That is our third significant digit, and that is one we are focusing on. Next, we check the digit that is next in order of significance, the one immediately to the right. The digit is a 2 that is less than 5. We therefore do not add 1 to this 2. Now if this were 5 or more, then we would have added 1 more right here, but it is not. Therefore we do not add 1 to 2, and the other digits to the left are not affected. They return as they are. In significant figure problems, trailing zeros are sometimes included in order to maintain the value of the number, like that. In this particular case, they are not adding to the number of significant figures nor affecting the value of the number in any way. Therefore, they may be omitted. And that is our answer, written to 3 significant figures. Sets. Let us show the universal set that contains whole numbers from 1 to 12. The universal set is the set of whole numbers from 1 to 12. H is the set of odd numbers between 4 and 12. 5, 7, 9, 11. Between 4 and 12. 4 is right here, so we start at 5. 12 is right here, we'll end at 11. No problem with that. J is the set of prime numbers that are in the universal set. That is our J. All of the prime numbers that are in the universal set. We need to complete this Venn diagram by including all of these elements. When completing a Venn diagram, it is appropriate to place the elements common to both sets first. Five belongs to H and J. 7 also belongs to H and J. Those elements are placed in the Venn diagram first. 11 is also a common element of H and J. Next, we have the remainder of elements that are in H. 9. Just a single one. Followed by the unique elements of J. Finally, there are elements of U that are not in any of H and J. Those that are unique to the universal set. Any other? Quite a bit. A few more. Any other? Right. Take note that after a universal set is given, the elements of the other sets must also be elements of the universal set. As mentioned in the statement of the problem, that the sets are subsets of the universal set. This problem is also testing a fickleness in some candidates in which prime and odd numbers are sometimes confused. So, the testing of this problem is basically investigating the state of minds of the candidates. Sometimes candidates confused prime numbers and odd numbers. So that's a test. Another test is that sometimes we are told that the elements that are in H are in the universal set by the statement that says H is a subset of the universal set. But some students, as soon as they see H is the set of odd numbers, they write down 100 odd numbers, neglecting the fact that those odd numbers are the only ones that belong to the universal set, and those are the only ones that pertain to this particular problem. Now is our favorite, I think, construction. Right. Use a ruler and a pair of compasses only. Construct a particular triangle LMN with angle LMN is equal to 60 degrees. MN is 9 centimeters and LM is 7 centimeters. All construction lines must be clearly shown. Let's go straight ahead and do that. First, draw the line MN is equal to 9 centimeters. There's our ruler, 9 centimeters. Draw. The angle LMN is 60 degrees. The middle letter is always the vertex at which the angle is located. Therefore, we will construct the 60 degrees angle at M. We need to be reminded that the red dot represents the point of the compass and the little blue triangle represents the point of the pencil. So in constructing the 60 degrees angle at M, place the compass point at M and make two arcs as we have them right there. We will then remove the compass point to the point where one of the arcs crosses or intersects the line that we have drawn. Then we make another arc the 60 degrees angle will be formed with this line and the line that goes from M through the point of intersection of those two arcs. The line that goes from M to L must be 7 centimeters. Draw the line in such a way that it goes from M through the point of intersection of the arcs, like so. 7 centimeters. Use your ruler, draw that line up to 7 centimeters. And if we are constructing a triangle, what do you know? That we need to complete it by drawing another line. Complete the triangle by drawing the line LN. Apart from that, we need to locate another point in such a way that the figure so formed will be a parallelogram. But before we do that, we need to measure the size of angle MNL. The middle letter is N, the angle is located at N. By placing the center of the protractor at the middle vertex, which is N, the line MN is the zero line, and take note of the position of the other line on the scale of the protractor. That is, the center of the protractor needs to go at N, because N represents the point at which the angle is located. So there we have the center of the protractor coinciding with N. One of the lines, we could probably use any one, but we are choosing to use the line MN as the zero line, and we are taking note of where this line actually is relative to the scale of the protractor, and the angle MNL is 48 degrees because this line is actually at 48 degrees on the scale of the protractor. It is measured to be 48 degrees. Next part of the problem, we need to locate a point in such a way that the figure so formed along with this triangle that we have right here is a parallelogram. We now need to locate K in such a way that KLMN is a parallelogram. Opposite sides of a parallelogram are equal. That is the principle that we are using in locating the point K. Opposite sides of a parallelogram are equal. We therefore need to get KL to be the same length as MN and KN to be the same length as ML. Before going any further, let's take a look at what that means. We need to get KL. We imagine that it's going to be somewhere out here. So KL will be the same length. KL will be the same length as MN. So we need KL to be the same length as MN. Also, KN to be the same length as ML. So K down to N. So K down to N is equal to the same as L down to M, or M up to L. So this one is to be equal in length with this one, and this one is to be equal in length with this one, and that is the principle that we will use. How do we imagine that we will achieve that? We will achieve that by first opening the pair of compasses from M to L. So we need to copy this length over here. Open from M to L, then place the compass point at N and make an arc. Open from M to L, then place the compass point over here and make an arc. then we need to copy the length of this line here up here. So we will open the compass from M to N. Then we will place the compass point at L and make an arc. That is our point K, right there. We are only required to locate K such that KLMN is a parallelogram, not to complete the parallelogram, just to locate L. We have located K. Our work is done. The equation of a straight line has the general form like that. Y is equal to mx plus c. There we have an equation of a straight line, but it is not in that form. The equation that we have there is not in the general form. We need to eliminate 3, that is multiplying y, on the left hand side in order that we will get it in that general form. We will achieve this by dividing the equation by 3. Divide the entire thing by 3. That is also equal to dividing this term by 3 and dividing the other term by 3. 2 over 3, and we have 6 divided by 3 is 2. Now that we have the equation in the general form, the equation is now in the general form. The coefficient of x is the gradient. The coefficient of x is the gradient as we have it right here. We have it right there. Gradient, which is m, is 2/3. Now we need to determine the equation of the line that is perpendicular to the one with this gradient, and that passes through 4, 7. What do? We know that if we have the gradient of a line, to find the gradient of the one that is perpendicular to it, we reciprocate the gradient and change its sign. By so doing, the gradient of the new line will be -3/2, and we will take advantage of the fact that we have the point 4, 7 through which that line passes. So y minus y1 is equal to gradient x minus x1 is a general formula that we use sometimes in finding the equation of a straight line. We know that m is the gradient, and we know that y1 is the y ordinate and x1 is the x ordinate. So making that substitution, we have y minus 7 is equal to -3/2 x minus 4. What do we know? This multiplying here is -3/2x. But negative multiplied by negative is positive, and 2 into 4 is 2. 2 multiplied by 3 is 6. Do not forget that negative multiplied by negative is positive. A positive 6. Then we may transpose this -7 to the other side. It will be added to 6, and we have y is equal to -3/2x plus 13. More functions. We need to determine, by making use of the information that we have here, the value of k. And I'm opting to use the first one that we have. 4 maps to 11. If that is the case, we need to determine the value of k. Let us say that the function x² minus k is equal to 11. But what is the value of x? the value of x is equal to 4 because this is the one that we are using. As a matter of fact, we are equating to 11. Therefore, we know that the value of x that we are using is 4. So substitute 4 into the equation. (16 minus k is equal to 11). All we need to do is transpose this negative k here and transpose this 11 there. K is equal to 5. As a matter of fact, we'll have 5 is equal to k, then k is equal to 5. If k is equal to 5, then x squared minus k will be x squared minus 5. Then we may use that to evaluate f of 3. In evaluating f of 3, we substitute 3 into the expression. 3 squared minus 5, 9 minus 5 is equal to 4, and that is f of 3. Next problem. In order to find the value of x for which f of x is equal to 95, we need to equate f of x to 95. And what is f of x? F of x is x squared minus 5. X squared minus 5 is equal to 95. There we have it. Find the value or values of x. The best approach is to take 95 to the left hand side where it becomes a negative 95. Transpose this to the left hand side. I know when some students see this, they are quick to take this one here. That is excellent if in the end you arrive at all of the possible answers. But I'm opting to take this 95 to the left hand side. We have x squared minus 5 minus 95. Whenever we add numbers that have the same sign, we add the values and the answer will take the same sign as in numbers that we have added. So x squared minus 100 is equal to 0. Factorize the difference of two squares and write down the solution of the equation. Difference of two squares, x plus 10, x minus 10. Then we are sure that x is equal to a positive 10 or a negative 10. Those are the things that we sometimes take for granted. By factorizing the difference of two squares, it is easier to see that the equation has two solutions. Surely easier than writing the square root of 100, by which we may neglect the fact that a number that has square root must have two of them. I'm saying that if we had x squared is equal to 100, we say x is equal to the square root of 100, and we are tempted to write down 10 as our answer. However, by using the difference of two squares and seeing the two factors, it is a little bit clearer that we have two possible answers, as we have them right here. The line graph shows the monthly sales in thousands of dollars at a school cafeteria for the period January to May 2010. Now, do not forget, in thousands of dollars. Thousands of dollars. And here we have it. Thousands of dollars. Our first problem is to complete the table. Notice that February is associated with $35,000. We just put 35 right there. Any other month is missing? April is associated with $15,000. May is associated with $10,000. Do not forget, thousands of dollars. The greatest decrease is shown by the segment of greatest slope. Now we are determining between which 2 months we have the greatest decrease in sales, and that is represented by what? The region of greatest slope, right there between March and April. Next, we need to calculate the mean monthly sales. And how do we calculate mean? The mean is the sum of entries divided by the number of them, or the number of entries. How many entries do we have? 1, 2, 3, 4, 5. After adding them, we will divide by 5. And we have 125 divided by 5, and we have 25. But do not forget that the sales will be in thousands of dollars, therefore $25,000. The sales for the month of June is equal to the total sales minus the sales of the other months. Why? Because the total sales is given to us, but we do not have the sales for the month of June. We have the sales of all of the other months, but we do not have the sales for the month of June. Therefore, we need to put the sales of all of those months together, and then what do? Subtract them from the total sales, and what will remain is the sales for the month of June. But we did not need to add them again because we have added them here already. So the sum that we get right here, which is 125, we use it right here again. Turns out that the sales for the month of June is 25. Do not forget, $25,000. What do we imagine? How do we comment on the sales for the month of June? The trend is showing a decrease in sales all the time, as we can see right here. June's sale is greater than May's sales. This is different from that which may be expected, which is contrary to the trend. We would have expected that the sales for the month of June would have been a little bit lower than that of May, but we realize that it is a lot more. Because of the trend, we are saying it should be less, it is more, it is a bit different from what we would have expected. Transformation. We are required to write down the coordinates of r and r prime. That's not difficult, but let's go. R, we go 2 units in the x direction, followed by 4 units in the y direction. 2, 4. What about r prime? R prime, we just go 2 units in the x direction and no unit in the y direction. 2, 0. Describe completely the transformation which maps triangle RST onto triangle R prime S prime T prime. What is the transformation that maps this triangle onto this one? The transformation is a reflection because the triangles are different in orientation. When triangles or figures are different in orientation, then the transformation that we assume is reflection. Differences in orientation are discussed in practice paper 9. I will therefore take the opportunity to discuss another feature of reflection. So we are going to take a look at the difference in orientation on practice paper 9. The next one that we'll be looking at after this one. But we are just going to take another look, which is at another feature of reflection on this occasion. In a reflection, the line joining points to their images are parallel. So there we have them. They are parallel. Lines that go from R to R prime is parallel to S prime, parallel to the one that goes from T to T prime. That is true for reflection. It is true for translation also. The same is true for translation. In translation, the lines are equal in length, but in reflection they are not. So in a translation, the lines that go from points to their images, all those lines are also parallel. But in a translation, they are all equal in length. In reflection, they are not necessarily all equal in length as we have them right here. So we are sure that this one is a reflection. This is a feature of reflection. The line joining points to their images are parallel. And they may be of different length. The mirror line must be perpendicular to those lines and also bisect them. These lines are what kind of lines are these? These are vertical lines. The mirror line must be perpendicular to them. Therefore, the mirror line has to be what? A horizontal line. Also, the mirror line must bisect this one. Therefore, from here to here is 4 units. That means the mirror line must pass at what? 2 units. So the mirror line will be right there at y is equal to 2. And that is your mirror line. The transformation is a reflection in the line y is equal to 2. Do not forget, in reflection, lines joining their points to their images are parallel but may be of different length. Different from translation. In a translation, the lines are parallel but they must all be of the same length. Also, the mirror line must be perpendicular to a line that is joining its point to its image. And it must bisect that line. That means it must divide it into equal parts. So we have 4 units here. It will pass right here. And that is how we describe a reflection. A reflection is described by stating its mirror line. Now we will perform a size transformation on this that is centered at, I will not say that yet, 0,4, and the scale factor is 3. We can enlarge a triangle by using our regular geometrical constructs, but we have the grid, so let us make use of it. The center is at 0,4 and the scale factor is 3. When we have the grid, we make use of it. We know our usual constructs and we may make use of that also. But the grid gives us an advantage in that we do not need to make so much calculation and also to be so precise and careful about where we put the points, because we are just manipulating the grid and the results, as we see, can be achieved quite easily. So there is our center of enlargement. How do we locate the image of each point? R is 2x units from A. If R is 2x units from A, then if we multiply that by the scale factor of 3, its image will be what? 6x units from A. its image will be 2 times 3 will be equal to 6x units from A. Right there. There we will have R prime. T is 5x units and 1 y unit away from the center. We have 5x units and 1 y unit. What do we imagine? 5 3 is 15 and 1 multiplied by 3 is 3. So multiply those by the scale factor of 3, and what do we know? Its image will be 15x units and 3 y units from the center of enlargement A. The calculation for S prime is not animated, but let us do it mentally. 3 x units. Let's see. 3, 1, 2, 3 x units and 1, 2, 3 y units. 1, 2, 3 x units and 1, 2, 3 y units. So we'll have it 9 x units and 9 y units away. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. There is where we will have S prime. We are provided with the area of this triangle, and we need also the area of this one. Simple calculation. To find the area, we take the area of this one that was given to us as 4 square units and multiply that by the square of the scale factor, which turns out to be 9. So 4 square units multiplied by 3 squared. So 3 squared is 9, which is the square of the scale factor, and we multiply that by the area of the object, and we get the area of the image. So we take the area of the object, multiply that by the square of the scale factor, and we get the area of the image. 2 ways in which this one is related to this one. Triangles are similar and corresponding sides are parallel. Triangles are similar if corresponding angles are equal. So the angle at R is equal to the angle at R prime. The angle at S is equal to the angle at S prime. The angle at T is equal to the angle at T prime. Those are similar triangles. Also, if we check the corresponding sides, this one is parallel to this one. This one is also parallel to this one. And this one is parallel to this one. So corresponding sides are parallel and the triangles are similar, meaning that corresponding angles are equal. Notice the lines that go from the center of enlargement through the initial points to their images, as we have right here. Center of enlargement, initial point to their images. In finding the image of S, the distance AS is measured, then multiplied by 3. The result then becomes the distance AS prime, and that is how we do that in normal construct. And we can do this on plain paper. We do not need a grid. Find the distance from A to S, multiply that by 3, and that is the distance from A to S prime, and we would have located S prime. It was not necessary to do that when we have the grid, as we have shown on the previous slide. The grid may be used to our great advantage, and also when we are performing other transformations, as we will see throughout Richard James Mathematics Resources. No matter the circumstances or how the images of the vertices are arrived at, one thing is consistent. The distance of the image from the center of enlargement is equal to the distance of the object from the center of enlargement multiplied by the scale factor. That is the reason for multiplying by 3 all of the time. So, in order to determine the position of an object, the position of the image of an object, we will measure the distance of the object from, we will measure the distance of the object from the center, multiply that by 3. That distance that we get will be the distance of the image from the center. The unit square is what forms the foundation of area. No surprise that area is given in square units. In forming the area of the image, each side of the unit square of the object has to be multiplied by the scale factor, as we will see in a minute. Therefore, the area that each unit square is transformed to is found by squaring the scale factor. Let us take a closer look at this on the next slide. There we have an object, a square of side L, and its image after an enlargement by a scale factor of f about A. Let us write down the area of the square. The area of this square is what? L multiplied by L is equal to L squared. On enlargement, each side is multiplied by the scale factor. So we'll have the scale factor is f, multiplying each side. So we have f times L, f times L. Then how do we find the area of the large square? The area of its image is therefore what? F times L multiplied by f times L. This may be simplified to be f squared L squared. So we see here L squared is the area of the object, f squared L squared is the area of the image. Therefore, in order to find the area of the image, we multiply the area of the object by the square of the scale factor. It is precisely for this reason that if we know the area of the object, we multiply it by the square of the scale factor in order to find the area of the image.